Good afternoon, Wolfpack, and welcome back to lesson 5.7, area of a sector. Area of a sector. The formula for area of a circle is area equals pi r squared, and r is the radius. This is something that you are probably pretty familiar with. You've heard radius a lot, and we've talked about the radius already. The radius is from the center of the circle to the edge of a circle. Pi r squared. So we're going to be using that formula today to solve some of our problems. Example number 1. A rectangular piece of cloth is 3 feet by 6 feet. What is the area? What is the area of the largest circle that can be cut from the cloth and round to the nearest square inch? So inside of that rectangle, I want you to draw a circle. You draw a circle, the biggest circle you can. Try to make it be a circle, not an oval. Well, the formula for area of a circle is area equals pi r squared. So if I'm looking for the if I'm looking for the area of the biggest circle possible, I am going to need to know pi, so I'm going to keep pi, and I need to know the radius of that circle that I drew. Well, if this is the center of the circle, I know the diameter is 3 because it's 3 feet tall. So that means the radius is 1.5. So my radius is half of 3, which is 1.5. So area equals pi times 1.5 squared. So area equals 2.25, that's 1.5 squared, times pi. And then you do 2.25 times pi. And when you round to the nearest square, oh, it says square inch. I'm sorry, guys, I should say square foot. That was a misprint. Okay, square foot. When you round to the nearest square foot, your answer is 7. So the largest area would be 7 feet squared. And some of you might be wondering, well, how did I know that the radius was 1.5? Well, think about it. I drew a circle, and the biggest the circle could be was 3 feet tall because the rectangle was 3 feet tall. So half of that would be the radius, that'd be 1.5. So our area is 7 feet square. Next up, we have blank circles are coplanar circles that have a common center, and that's the word concentric. We have 2 circles that are in the same plane, so they are in the same area and they share a common center. They're called concentric. They look like a circle on top of a circle. We're going to find the area of the shaded region. Well, the shaded region is that lit around it. What we're going to have to do is find the area of the entire big circle, find the area of the smaller circle, and then subtract them. So the formula for area is pi r squared. And the larger circle has a diameter of 12. So its radius is 6. So its area is pi times 36. Its area is 36 pi. 36 pi meters squared. But I don't need all of that. I need to get rid of all of the white. Okay, so I'm going to have to find the area of the white and subtract it. Okay, I should not have covered up the 8 so I don't get confused. So the area of the smaller circle is also pi r squared. Its diameter is 8, so the radius would be 4. 4 squared is 16. So its area is 16 pi meters squared. So the larger circle is 36, the smaller one is 16. So my area is 36 pi minus 16 pi. My area is 20 pi meters squared. And this is called leaving the answer in terms of pi. In terms, like the term, of pi. We left the answer in terms of pi because I still have the pi. That pi represents a number, which you guys already know. Pi represents 3.1415, and so on. Okay? So the answer is technically 20 times 3.1415, which would be like 60 something. But I'm leaving it in terms of pi, which is a very accurate way to put your answer. So if you just write the answer as 20, that's wrong, because it's not 20. It's 20 pi, which means 20 times pi. And you'll see answers that allow you to keep them in terms of pi. And often, when I'm solving problems, I leave everything in terms of pi until the very end. Because it's easier to subtract 36 and 16 from each other than it would be to subtract like 92.55 minus 57.98. So if I have nice small whole numbers, they're easier to work with. Okay? So the area of the shaded region was 20 pi meters squared. We're going to do examples 3 and 4 in class. So let's turn it over to the back side. Area of a sector. Area of a sector is finding a portion of the whole area of the circle, or a piece of it. It's like finding the piece of the pie. I'm not finding the whole pie, I'm finding the piece of it. And the area formula is still very similar. You still have area equals pi r squared, but now you're multiplying it by a fraction. And that fraction always has a denominator of 360 because there are 360 degrees in a circle. Okay? So your area is a fraction. An area of a sector is a fraction of the whole area. And so M is the central angle, or arc measure. So let's do example 5a. So my formula is area equals pi r squared. That's normal. You're familiar with that. But I'm multiplying it by a fraction. My denominator is 360, and I have to figure out what my numerator is going to be. So area, and I'm going to be finding the shaded sector, so that means this portion right here, equals pi r, my radius is 3, times the measure of the arc or angle over 360. Well, this angle is 210 degrees, so it's 210 over 360. If you notice, this angle is marked as 210 degrees. So that means the angle and the arc are 210 degrees. So 210 over 360. Okay, I'm going to write a little bit over to the right. So area equals 9 pi times, this reduces to 21 over 36 because I can divide both sides by 10. And then 3 can go into 21 7 times, and 3 can go into 36 12 times. So now I've reduced 210 over 360 to 7 over 9. Okay? And so now I have area equals 9 times 7 is 63. 63 pi over 12. And 63 and 12 cannot reduce, and it wants me to round it to the nearest hundredth. Nearest hundredth. So you'll take 63, multiply it by pi, hit the pi button on your calculator, and then divide it by 12. And when you round to the nearest hundredth, you get your area equals 16.49 inches squared. Remember, area is always squared units. Area is always squared units. Let's do another one. Example 5b. Again, your formula is always area equals pi r squared because you're finding the area of a circle, but you're finding a portion of it. So you need to know the measure of the angle or the arc, and you'll be dividing it by 360 because in its circle and its entirety is 360 degrees. Okay, so you're trying to figure out what piece of the 360 do I need. Area equals pi. The radius is 8 inches. Times the measure of the angle. 60 degrees is the shaded angle over 360. Area equals 8 squared is 64 pi. I know I can divide both sides by 10, so that's 6 over 36, but also 6 can go into 6 one time, and 6 squared 136, 6 times. So I have 64 pi times 1/6. So now I have area equals 64 pi over 6. I can reduce both of those by the number 2. So this becomes 32 pi over 3. And 32 and 3 cannot reduce anymore. So I'm going to multiply 32 by pi. And that's probably going to be somewhere like 90 something. And then we'll divide it by 3 and round to the nearest hundredth, and we get 33.51 inches squared. The area of just this portion, just the shaded portion, is 33.51. Just this portion. Okay, if I wanted to know the whole portion, it would be 64 pi, and that's going to be over 180. But I needed just 1/6 of it. That shaded piece was only 1/6, so I needed 1/6 of the area. We will do examples 6 and 7 in class together, but if you have any questions at all, please make sure you're writing them down. But guys, I do not want you to overthink this. This is finding the area, but once you found the area, you're multiplying it by a fraction because you're finding a piece of the area. So it's just finding a piece of the area. We'll go over a lot together in class, but I don't want you to get psyched out. Have a great day, and I will see you next class.